Bright Tuty. Every student matters.
Hello learners, welcome to your math lesson on mensuration. In this particular lesson, we are going to learn about the areas. I hope you do remember in the previous class on mensuration, we learned about the perimeters, and now in this lesson, we'll be learning about area. So let us begin with by the end of this lesson, you will be able to understand what do you mean by area. You will be able to estimate the area. You will be able to learn how to work with the area of rectangle and square. So let us begin with the first question, what is area? Right. In geometry, the area can be defined as the space occupied by a flat shape or the surface of an object. Let's read this again. In geometry, the area can be defined as the space occupied by a flat shape. As you can see here in the example, here this particular shape, that is a rhombus, then this particular circle, this triangle, they are all flat shapes, right? And the particular area that is enclosed by these shapes, that is shaded here, this is called as the area of these respective shapes. Now it says that the area of a figure is the number of unit squares that cover the surface of a closed figure. Area is measured in square units such as square centimeters, square feet, square inches, etc. Here you can see that these small little squares are shown on which these flat surfaces, these flat figures, they are made, right? So when we say what is area, area is basically when we divide this particular flat shape into small squares, okay? So the total number of squares that we have, it is basically the area of that particular shape. So usually when you write down the area, it is measured in square centimeters, square feet, square inches, etc. Okay, now let us learn more about this. But before that, I want you to think, where do you think you use these area in your real life? Right. So here are some examples. If suppose you are sitting in a room and you think that I need to put a little carpet on this room. So you need to find what is the measurement of this particular room in order to get that particular size of carpet. Is that right? So what do you need? You need to know what is the area of your room. So here area comes into picture. Second thing that is given, getting the right amount of concrete for a new driveway. So what you need to do, you are going to put the concrete on the driveway. So you need to know how much area needs to be covered. Similarly, if you want to paint a certain wall or something, so you need to find its measurement. And in the measurements, you are requiring to measure its area so that that particular amount of paint will be used. Now let us learn formally about area using some maths. So now area refers to the space enclosed by a closed figure. Simple definition, area refers to space enclosed by a closed figure. Like here you can see a rectangle is given and everything that comes inside this rectangle, every part that is shaded, it is called the area of this particular shape, that is a rectangle here. Now it says to find the area of any irregular closed figure, we can put them on a graph paper with the squares of 1 centimeter cross 1 centimeter, and then we can estimate the area for that figure by simply counting the area of the squares covered by the area. Let us see one example here. This is an example where you can see a figure is given and this figure is kept on a graph paper, or we can say that where you see these little squares. So the given figure is made up of line segments and is covered with some full squares and some half squares. So let us see how we can find the area of this camel shaped figure, right? So now what is required is that we need to find how many total complete squares are there in the picture. So see, full squares in the figure is 32. Which are the full squares? Look here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Go on and on and on and read how many squares are the full squares in this shape. and you will find the answer, that is 32 squares are the full squares in the shape. Now we have, look at here, this is half of the square, right? This is also not a complete square. Again, this is again half of a square. Similarly, look here, it is again half of a square. So we see at some places we have got full squares and some places we have got half squares. So what will we do? In order to find the area, we are going to multiply the full squares with one square unit. So one square unit, what do you mean by one square unit? It means that, say, this is your block and this particular block is either 1 centimeter, 1 centimeter, 1 centimeter, 1 centimeter from all the sides. So it's a square with 1 centimeter of each side. Instead of square, we can even have a square instead of a square in centimeters, we can have a square in meters. So it can be 1 meter, 1 meter, 1 meter on all of its sides. So now this particular square is referred to as 1 squared centimeter square. This particular square is 1 squared meter, or we can write this as 1 meter and then we put a small 2 on the top to write 1 meter square. Similarly, we can write 1 centimeter. On the top we write a small 2, it refers to as centimeter square. Okay, so this means that why we are writing this 1 square unit. This word unit means that you can either write centimeter here, you can write meter, kilometer, inches, millimeter, any unit of measuring something. Basically a square you can put here in place of unit. Okay, so here how many full squares did we have? We had 32. So we are multiplying 32 by 1 square unit and the answer is 32 itself with the square unit. Now what is the area of the half squares? So what is it? 21 squares were half squares. We multiply it with half a square. So we say that instead of this complete square, what are we having? We are having a half square, just this much. Okay, the shaded part that you see. Now in order to find what is the total area covered by the figure, we add these two values that we have calculated. Okay, on adding them, we get the answer as 42.5 square unit. Okay, so if you think that this particular part is not much clear to you, no worries, we are going to do examples and then I'm sure you will understand it even better.
Look at the animation.
To find approximate area of a leaf. Place the leaf on a squared paper. Draw around the leaf carefully without disturbing its position. Now count the number of squares enclosed within the shape as follows. Count a full square as 1. Count a more than half square as 1. Ignore a square which is half or less than half. The area of the leaf is 20 square units.
Starting with a simple shape, we are going to find the area of this shape that you see in front of you. Now, what do we need first? In order to find the area, we need to find the number of squares that we see in this particular shape. So let us write exactly how we see here, right? So we are going to write what are the number of full squares. So full squares, so how many full squares? Here I can see 1, then this is 2, 3, 4, 5, 6, 7 and 8. Okay, 8 are full squares in this particular shape. Now how many half squares do we have? Let us write half squares. So it is here, this one I'll just choose the other color. Say black. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and that's not even 1. So let's say 15 half squares. Now I want you to make this very clear in your head. What we are doing, we are estimating the area. Okay. We are not calculating the exact area because we are not measuring it using some inchy tapes or any measuring tape. We are not doing that. We are just counting the squares in full and halves. Okay, so if your answer is not, it's not going to give you the very much appropriate answer. It's going to give you approximate answers. Okay, now let us write it down. Right, so let us write down here what we have written here. After we have written down what is the number of full squares, what is the number of half squares, what we need to find next, what is the area covered by full squares. So let us write area covered by full squares. So what is the area? That is 8 multiplied by, what do we times it? 1 square unit. So unit can be anything, meter, centimeter, millimeter, kilometers, anything. Okay, so the answer is 8 square units, right? So this is for the full squares. Now let us find the area covered by half squares. So the area covered by half squares is, we have got 15 half squares, so we multiplied by half squares and with some unit. Okay, so the answer is, if we do half of 15, it is 7.5 squared unit. Now let us find what is the answer, that is the area of this particular shape. So the total area that we have is equal to 8 plus 7.5, and this is in square units, right? So what is the answer? 7 plus 8 is 15, so it is 15.5 squared unit. I hope this is clear. If not, no worries. Let us try another question to be even more clear with this. So it says, by counting squares, estimate the area of a figure. Every time you are going to work with such kind of images, you are always estimating the area. I made this already clear to you. This part comes under the estimation of area. Okay, so now let us calculate how many full squares we have. So full squares is equal to, so here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Clearly we have got 11 squares that are full. Now what is the area for full squares? So the area for full squares is 11 times by 1 squared unit. Okay. Now this gives 11 squared unit as the answer itself. Now what do we need to find? We need to find the half squares. So let us find what is the number of half squares in this particular image. So it is 1, 2, 3, 4, 5, 6, 7 and 8. So it is 8. Now in order to find the area that is covered by half squares, it is 8 multiplied by half unit squared, right? So it is 4 squared unit. Now let us find what is the total area. So the total area of this particular shape that is given to us is 11 plus 4, that is 15 square units. I hope now it's more clear. Let's do another one then. Here it says, by counting squares, estimate the area of the figure. Again, I'm highlighting this point, estimating the area, okay? So here I can see there's only one square that is the complete square, this one here. Only this particular square is complete. Now look how we are doing this particular question. Clearly what we see, I'll just highlight this area once again. So what we see here is that in this, I'll just mark all the squares that we have, okay? So that it's more clear to see how many squares we have got in this particular leaf structure, okay? So we are calculating the area of this leaf, right? So now clearly you can see that we have approximately 2 squares that are full. So let us write down that full squares are 2. So now look what I'm doing now. Let us write down what is the number of squares that are more than half. Like if this is the complete square, this is exactly half of it, right? So this part is exactly half of this. However, you can see that in every image, some squares are very small. For example, this one here, this part that I'm shading. This is a very small part of a square, right? And look at this part here. This is almost equal to the full square, but this is not a full square. Okay, so now if I'm counting this one as 1 and I'm counting this one as 1, so it's unfair. I hope I'm making this point clear. If I'm counting this small little shaded part as 1 square and I'm counting as a half square and I'm counting this almost full square as a half square, then I'm being unfair to these squares. So what I'm going to do, see, almost full, okay, almost full squares. So let us write down the number of almost full squares. So this is 1, I'll just shade those squares. This is 2, right? Then this is 3, 4, 5, okay? Then we have got, this is half. Then we have got 6, right? So these are almost half squares, or we can say greater than half squares. Okay, either you write almost full squares or you can write more than half squares. So instead of almost full, let us write more than half. Okay, more than half squares. So it's 1, 2, 3, 4, 5. So 5 squares are more than half. So when we see that 5 squares are more than half, we are going to keep the number as 5. Okay. So now, which squares do you see less than half? Let us write them. Less than half. It is 1, 2, 3, 4, 5 and 6, 7. So 7 squares are less than half, right? So what we are going to do, we are going to see that this particular part, this is less than half, we are going to convert it into 0. We are not considering this part, okay? What we have done, we have taken into the consideration those parts which were more than half as the complete squares, okay? See this difference again. Earlier when we were doing this question, what we did, we multiplied them by half squares. Now what we are doing, we are thinking that let's draw another table. I'll just draw a table here for you so that it's even more clear what we are talking. Okay. Now see again. Let me write here full squares. Okay. Almost full, or let me write more than half. So more than half. Then I'm writing less than half. So these are less than half squares, okay? So now, what is the number of full squares that we have? It is 2, okay? Now, what is the number of more than half squares? It is 1, 2, 3, 4, 5. What is the number of squares that are less than half? It is 7, okay? Now, what are we doing? These two numbers remain itself. Okay, the full squares and more than half remains the number itself. However, this particular number, we don't consider it and we consider it as 0. Okay, these squares which are less than half, we are not considering them. So now what is the area of this particular leaf? So area of leaf is equal to, we are going to times these two numbers, that is 2 plus 5 multiplied by 1 square unit. So now we are not considering that here. We were multiplying by half square unit, right? Now what we are doing? We are not considering any half part. Anything which is less than half, we are making it 0. Anything more than half, we are making it a 1. So now what is the area of this leaf? This is estimation. It is 7 squared units. Okay. This is how we have estimated by considering more than half and less than half. Okay.